Every time you look at the stars, you're seeing history unfold. The light reaching Earth tonight started its journey years, centuries, or even millions of years ago. Let's explore how these cosmic time capsules tell their stories. Light acts like a natural time machine, carrying information across the universe at an incredible speed of 186,000 miles per second. When we look at the Andromeda Galaxy, we're seeing it as it appeared 2.5 million years ago. The stars we see might not even exist anymore. We're watching their past lives play out in real time. Think of it like watching a delayed broadcast of a sports game, except the delay isn't just a few seconds, but potentially millions of years. The light from these distant objects brings us valuable information about their temperature, chemical makeup, and movement. Each beam of light is like a message in a bottle, floating through space, carrying stories of cosmic events that happened long ago. This amazing process lets astronomers study the history and evolution of our universe just by looking up at the night sky. Stars have a unique way of revealing their age to us, and it's all in the light they send our way. When we split starlight into its rainbow of colors, what scientists call a spectrum, we can read it like a birth certificate. The colors tell us what elements are present in the star, how hot it is, and even how fast it's moving. Younger stars tend to shine bright blue and contain more hydrogen, while older stars often glow in redder shades and show signs of heavier elements. Think of it like examining tree rings, but instead of counting circles, we're looking at light patterns. Modern telescopes can capture these stellar fingerprints with amazing detail, helping astronomers figure out if a star is a cosmic teenager at just a few million years old, or a senior citizen billions of years into its life. Let's zoom in on Betelgeuse, a bright red star in the constellation Orion that's about 550 light-years away. The light we see from Betelgeuse today began its journey around 1473. That's right around when Leonardo da Vinci was painting. This means when we look at Betelgeuse tonight, we're seeing it as it appeared during the Renaissance. The star's brightness has been changing recently, making astronomers wonder if it's getting close to becoming a supernova. But here's the fun part. If Betelgeuse exploded in Napoleon's time, we still wouldn't know about it yet. The light from that event would still be traveling through space, like a cosmic news report that's still on its way to Earth. This really shows us how looking at stars is like having a time machine that lets us peek into different periods of history. Some stars we see today are like cosmic fossils, born when the universe was just getting started. These ancient stars, often called population 2 stars, formed about 13 billion years ago when space was mostly just hydrogen and helium. They're different from younger stars because they have very few heavy elements. After all, they formed before most of these elements existed. These stellar seniors are mostly found in the outer parts of our galaxy and in globular clusters, big groups of old stars that orbit our galaxy like tiny satellites. By studying these stars, astronomers can piece together what the early universe was like, similar to how archaeologists use dinosaur bones to understand Earth's past. The light from these stars carries information about the universe's first billion years, making them incredibly valuable for understanding how everything we see today came to be. The colors of stars tell us amazing stories about their lives. Blue stars are the hot shots of the cosmos, burning at incredibly high temperatures around 30,000 degrees Fahrenheit. They're like cosmic sprinters, living fast and dying young. White stars, like our sun, are the middle-aged ones, steady and reliable. Then we have the red stars, which are actually the cooler ones, burning at lower temperatures. Think of them as the elder citizens of space. When we see a red giant like Antares, we're looking at a star in its later years, swollen up to hundreds of times its original size. These different colors aren't just for show. They're like cosmic name tags that tell astronomers how old a star is, how hot it burns, and what stage of life it's in. Looking at the night sky is like having multiple windows open to different times in history. When you gaze at the Pleiades star cluster, you're seeing light from 400 years ago, around when Galileo first pointed his telescope at the stars. At the same time, the light from the center of our Milky Way takes about 27,000 years to reach us, showing us what was happening during the Ice Age. The Andromeda Galaxy's light started its journey when our early human ancestors were just learning to use stone tools. It's amazing to think that every time we look up, we're seeing a mix of light from different moments in time, all arriving at our eyes at once. Each point of light in the sky is like a time capsule from a different era, creating a beautiful cosmic museum where ancient and more recent history blend together. When massive stars end their lives in spectacular explosions called supernovas, they send out one final light show that travels across space for millions of years. These cosmic fireworks are so bright they can outshine entire galaxies. Astronomers catch these ancient explosions using powerful telescopes that scan the sky every night. When they spot a sudden bright flash where there wasn't one before, it's like receiving a delayed message about a star's dramatic finale. The fascinating part is that these explosions we're seeing today actually happened long ago, sometimes when dinosaurs still roamed the Earth. The light carries detailed information about what elements were created in the explosion, helping us understand how the building blocks of life spread throughout the universe. When you look at stars tonight, you're always seeing them as they were, not as they are right now. This happens because light takes time to travel, even at its amazing speed of 186,000 miles per second. Think of it like watching a live sports game from another country. There's always a slight delay in the broadcast. The closer stars, like Alpha Centauri, show us their appearance from about 4 years ago. Stars near the center of our galaxy show us how they looked about 27,000 years ago. This delay means that if a star exploded right now, we wouldn't know about it until years, decades, or even centuries later, when that final flash of light finally reaches Earth. It's a reminder that space is so vast that even light, the fastest thing we know, takes a very long time to cross it. When we look at distant galaxies, we're actually seeing what the universe looked like when it was much younger. The farthest galaxies we can spot are over 13 billion light-years away, showing us how the universe appeared shortly after the Big Bang. These ancient galaxies look quite different from the ones we see nearby. They're smaller, less organized, and filled with younger stars. The Hubble Space Telescope acts like a time machine, capturing images of these cosmic youngsters. It's similar to finding old family photos that show how different things were long ago. Some of these early galaxies were busy making new stars at an incredible rate, like cosmic factories working overtime. By comparing these ancient galaxies with newer ones, astronomers can track how galaxies grow and change over billions of years. The night sky our great-grandchildren see will look slightly different from ours. Stars are constantly moving through space, changing their positions over centuries. Barnard's star, the fastest moving star we can see, will shift noticeably in just a few hundred years. Some stars will grow brighter or dimmer, while others might surprise us with dramatic endings. Betelgeuse could go supernova any time in the next 100,000 years, giving future generations a spectacular light show. Our neighboring Andromeda galaxy is slowly getting closer too, though it won't collide with our Milky Way for about 4.5 billion years. The North Star will also change. Polaris won't always point north, and in about 13,000 years, Vega will become our new North Star. Thanks for joining us on this cosmic journey through time and space. Every night, Sky tells countless stories from different eras. If you enjoyed this stellar adventure, hit like, subscribe, and share to help others discover these cosmic time capsules.